Okay, thanks for this nice introduction and hello everybody. This next talk is about Angular for huge enterprise applications, and as Stefan already said, I'm Manfred, I'm a trainer and consultant for Angular, and I'm helping a lot of companies with using Angular in big enterprise software projects. I'm also part of the Google Developer Expert team, and my latest project and product is an Angular workshop. I'm doing it on site as well as a public workshop, and it is also about enterprise architecture with Angular. So I want to start with a picture. This picture shows in a simplified form the typical model structure of an Angular application. Normally we have something like a root module that is called app module most of the time. We have something like feature modules. Each use case gets a feature module, and when the use case is too big, we can split it down into sub-feature modules. And then, of course, we have one or several shared modules. Shared modules with common stuff like an address component or common validation logics and so on. And in most of the cases, each and every module gets a folder of its own. This is what Angular provides us for substructuring a huge application into tinier parts, modules as well as subfolders. And in big enterprise applications, unfortunately, this isn't enough. And this is exactly what this talk is about. When I will present you several things. I will talk here about NPM packages as a further mechanism to break a whole big application down to tinier parts, tinier, maintainable, reusable parts. I will talk about the monorepo approach as well as about microservices. So first things first, let's start with NPM packages. I assume every one of you has seen an NPM package before. It's quite an easy thing. It is just a folder with a node modules folder. This node modules folder contains other packages we depend upon. We have our own stuff in here, our own JavaScript files, our own HTML files, our own CSS files, and so on. And there is a package JSON with metadata about your package. This is more or less what NPM packages are about. So in theory, it's quite an easy thing, in theory. In practice, you have to respect a lot of tiny aspects, especially when it comes to Angular development. For instance, there is this Google document called the Angular package format. It is quite long and it describes all the things you have to respect to make your library work seamlessly together with Angular, but also with all those optimization techniques in the Angular world. Optimization techniques like, for instance, AOT and tree shaking. And when you read through this document, you will very likely look like this guy here. You will look like an owl after the forest fire, because there are so many details in there. And of course, each and every detail makes sense to make an optimized library, but it is just overwhelming. And I have a good message for you. There are tooling out there, tools that help you to align with the Angular package format. A very popular tool is ngpackager. It is a tool that can be used very easily. It points to your source code and it tries to compile your source code down to an NPM package that aligns with all those details of the Angular package format. And the best message is, since 2 or 3 weeks, the Angular CLI uses ngpackager. The folks in the CLI team just used the ngpackager tool. They wrapped it and they included it into the CLI 6. And so the CLI 6 can down-level your source code to NPM packages. It's quite easy to use it. Of course, you need to install the CLI, and then you need to new up a new project. And after this, you can create a sub-project within this project. For instance, by using ngGenerate library. This is new here. ng-generate library creates a sub-project with a library as part of your overall project. And you can do the same with applications. For instance, here I've added a playground application to my project, a playground application that helps me to test my library. Yeah, and then of course you can serve your playground application, and when you've done, you can build your whole library project. And after this build step, that is leveraging ng-packager, you have everything you need to publish something at your NPM registry. When you look at your folder structure, you see something like this. The new CLI is creating a subfolder projects for you, and this folder contains all your sub-projects like your applications and your libraries. You have also your source folder you are used to, and the source folder is more or less for single projects, for projects that contain just one Angular project and not sub-projects. And when you go with sub-projects, you will very likely want to get rid of this folder, of the source folder. In this case, just drop it and perhaps update your Angular JSON with regards to it. Okay, this is quite easy since 2 or 3 weeks since we've got Angular 6. When you have down-leveled everything to an NPM package, you have to deploy your package. And this is also quite easy. Everything you need to do is to increment the version in your package JSON. For this, you can use something like npm version. And then, of course, you have to build your library again, and then you can publish it. The nice thing about this is that publish has this switch registry, and the switch allows you to point to a custom in-house registry. Without this flag, you will publish your library out there in the internet, in the official registry, but when it is just for your colleagues, then you can use this to point to your own installation. And the same holds true for npm installing stuff. npm install also comes with this -- registry switch. There are some alternatives when it comes to set the registry. For instance, you can use this command here, npm set registry, to set your default registry machine-wide. And there is also a lesser-known feature. You can create a .npmrc file in your project's root, and this file can also point to your default registry that is used for your very own project. This file is an ini file. I like this homage to the 90s, you know, DJ Bobo and Modern Talking and ini files. Nice. So, of course, you have to choose for a registry when you want to make in-house development. And when I'm looking at my customers, I'm seeing one tool very regularly. It is Nexus. Who of you is using Nexus? Some of you. It's mainly found in the Java area. I have some .NET customers that are using Nexus too, but most of my Nexus customers are Java customers. And the same holds true for Artifactory. Who is using Artifactory? Yeah, okay, cool. Also quite popular in the Java community. Do we have .NET developers who is using Team Foundation Server? Yeah, cool. It also supports npm packages now. And my favorite is Vertaccio. It's an Italian word, Vertaccio, and it is a very lightweight npm registry. It is really easy to install, just npm install it globally, and then you can run it just by typing in Vertaccio, and you get your full npm registry for in-house development. There are even README files out there that shows you how you can wrap this Vertaccio command in a Windows service as well as a Linux daemon. This approach I've talked about has several advantages. When we go with npm libraries and an own npm registry, we can distribute our work. We can distribute our libraries amongst our colleagues or amongst the whole world of open source development. We get also versioning, because this is a very important concept of MBM. We could create several versions, and not each and every customer has to use the newest version all the time. And we get a decoupling between the library authors and the application authors. Those are the advantages of using NPM packages. And on the next slide, we will see some disadvantages. Look at these. So it turns out that all those advantages are also disadvantages. Let me elaborate on this. For instance, when it comes on distribution, it is annoying to create new libraries just to subdivide a huge project into tinier pieces. It is really annoying to create all the time a new sub-project that needs to get published via an NPM registry. And I'm quite sure this will prevent us from creating further libraries. So we won't end up with as much libraries as we or our project would deserve. And of course, this isn't good for maintainability, this isn't a nice thing for reusability and for the overall architecture of our Angular application. When it comes to versioning, this means that we have old versions out there, old versions of our library, and this also leads to version conflicts. And somehow, especially when it comes to in-house development, when it comes to the point where we want to subdivide a huge project into tinier parts, we want to force everyone to use the latest version of our libraries, just to prevent this mess with version conflicts. It is not the same case with open source development, but when it comes to in-house development, when it comes to just one project, we want to force everyone into this. And also deep coupling can be a disadvantage, especially when the library authors are the same as the application authors. Talking to yourself isn't fun at all, especially when you have to talk to yourself by the means of an NPM registry. When you like this, please visit a doctor. He will have some medicine for you. Okay, so we have a lot of advantages, but also a lot of disadvantages when it comes to NPM packages. And one solution to all those disadvantages is the monorepo approach. It is quite popular nowadays. I don't like the word monorepo. I would prefer the word workspace, because this is what it is about. A workspace, a common directory where you put all your sub-projects into. That means when you are subdividing a huge project into tinier pieces, you put all those sub-projects into this one workspace, into this one repository. Here in this case, I've subdivided my sub-projects into two parts. I have applications and libraries. On a technical basis, this is just the same. The only difference is that the application can be executed. The library can't be executed. It is used by another library or by an application. The best thing about this is the common nodes modules folder. This means, you see it here, each and every sub-project has the same dependencies, the same node-based dependencies. And of course, this prevents version conflicts. Just imagine what would happen when you would use, for instance, Angular 5 here and Angular 6 there. Probably hell would break loose when you try to use both libraries within the same project. And this prevents this by using this folder structure. There are also other advantages. Everyone has to use the latest version of all the libraries, because the latest version of the libraries is just in the folder next to your application. You don't have another chance but using this very newest version of a specific library. As mentioned before, you don't have version conflicts. And you don't have the burden of distributing libraries just to split your huge project into tinier pieces, or to put it in another way, you don't have to talk to yourself by the means of a registry. Creating new libraries is very easy. It's just a matter of adding a new folder. And there is a lot of experience with this monorepo structure out there. For instance, at Google or Facebook, they are using this approach very heavily. To tell the whole story, this monorepo approach comes in two flavors. The flavor I'm talking here about is the so-called project monorepo. That means that everything that belongs to one project, to one software system, is put into this folder structure. And you can very likely compare it with concepts you already know. For instance, workspaces in Eclipse. Who has used Eclipse so far? A lot of people. There you have this workspace concept where you also can put a lot of related project into one folder, into one place. And when you go with Visual Studio for .NET development, you know Visual Studio Solutions. It's also some kind of project repository, of project monorepo that contains all your sub-projects. There is also a company-wide monorepo approach. It is used quite heavily at companies like Google or Facebook. What this means is that they have just one repository for all their software projects. This seems to be quite overwhelming, and this also demands for special custom toolings. All those companies have created custom toolings that prevents them to check everything out. They have custom tooling so that they can just check out what they need. They can just check out the parts of this monorepo they need for their very own project, their applications, as well as their libraries. And I think for most of us, this could be too much. But I think also for most of us, when you aren't Google or Facebook, the project monorepo is a nice thing because it holds everything together that belongs to your project. Perhaps you heard the saying that everyone at Google is using the newest version of Angular all the time. This is not because they want to, but because they have to. They have just one monorepo for everything, and Angular is just one dependency, one additional library in this very same folder structure, so they don't have another chance but using the newest version of Angular. This is one of the upsides of this company-wide monorepo approach. But for the beginning, I would really recommend to start with a project monorepo. The good thing about monorepos is that you can move back and forth. That means that you can take a library, for instance, this validation library here, and put it into an NPM registry as an NPM package. That means when you say, hey, this part is major enough and other project teams need it too, you can just take it out and provide it for other people. When you say, hey, I don't like this idea, I don't want to have an own NPM registry for my company, then you could also go with a Git repository. You could use something like Git submodules. It is, if you ask me, a lesser known feature of Git. Who has used submodules so far? Oh, pretty much of you, cool. So submodules are just a way, I put it in a nutshell, in a very simplified way. It is just a way to check out an existing repository into another repository. And you can do this in a read-only manner, but also in a read-write fashion. Both is possible here. In addition to that, you can also leverage some tooling. There is a lot of tooling out there that helps you with monorepos, and I think the most popular tooling in the Angular world is NX. NX is a little library combined with a code generator that helps you to get around with monorepos. And the best thing about this is, it is not an own development, it is just a bit of sugar on top of the Angular CLI. It is just using some well-defined extension mechanisms the Angular CLI provides to get more out of it. This NX provides a folder structure for monorepos, and it also provides additional features. For instance, it can find out which applications are affected by the latest changes, and then just those applications need to get recompiled. That saves you a lot of time for recompiling your stuff during development. There is also some tooling in there to format your code. Of course, when it comes to big enterprise software, you want to have a common coding style. And you don't want to discuss with your colleagues about the coding style. You want that the coding style is done in an automatic way. And so it is cool to have a code formatter in there. This is the best feature. You can restrict which library is allowed to access which other libraries. And this is an important thing because this prevents that each and every library is accessing each and every other library. You don't want to have such a situation. That would be a situation that comes with very little maintainability. When everything depends on everything else, you cannot exchange your stuff. And it allows also to visualize your library structure. It is doing a bit of graph drawing to get you a nice diagram of all your dependencies between your applications and libraries, and it also scaffolds a lot of boilerplate. Okay, I would say enough for theory. Let's switch to an example. Let's switch to a demonstration. What you see here is a sample application I'm using quite often to demonstrate all the aspects of Angular. It's about searching for flights, and sometimes it's also about finding flights. So let me try this. Yeah, it's a very simple CRUD application, as you see here. Let's have a look into the source code of this. So when we look at the folder structure here, then we see an apps directory as well as a libraries directory. And guess what? The apps directory holds my applications. Here I'm going with a flight administration application as well as with my flight app, the customer-facing one. And here we have some libraries like a flight API or a lockerlib or another library. The flight, go away here please. The flight API contains a lot of services that are accessing my backend. In the flight API, I have a lot of logic that is doing REST calls. So let us have a look into this API. Here we see an index.ts. This index.ts is the best thing about libraries. It's a so-called barrel. And you can also think about it as about the public API of your library. Everything the consumer of the library needs to know gets re-exported here in this so-called barrel, in this facade for your library. And for this, you are using this nice export statement with an identity crisis, as I'm calling it. Identity crisis because it is somehow a mixture between import and export. It imports something from this and that file and re-exports it. And so you can do a bit of information hiding, and this means you can decrease the complexity of your library. You can show the consumer what he has or she has to care about and what they don't need to care about. Here in this case, I'm exporting an Angular module, of course. I'm exporting a flight entity as well as a flight service to access my backend. Let's also have a look into my application. When we look into my flight app, then we see in the app module that I'm importing my flight API module from my library. And I'm pointing to my library by the means of this mapped name here. This mapped name looks like the name of an NPM installed package, but it isn't. It is just a library in the next folder. And when we scroll down, we see that Flight API module gets imported into my app module. It seems like there is a static function for root that is installing my module for the root module of the consumer for the root module of the application. Perhaps you are wondering why TypeScript knows that this name points to my library folder. And the answer to this can be found in the dsconfig JSON. So let's have a look into it. The dsconfig JSON comes with some path mappings. And here I'm just saying, hey, everything that begins with the scope flat workspace is redirected to my library folder because this is the location where all my libraries are. And when you have done, when you say, hey, now I want to exclude my libraries, I want to put my libraries in an own NPM package, then you can point here to the folder with your own NPM package. It is just a matter of switching this line here, and so the TypeScript compiler will use the down-leveled NPM package, the compiled NPM package, instead of your source files. Perhaps you've noticed I'm using a command here in the middle of my JSON file. This isn't allowed, but if you ask me, sometimes we have to risk something. This really makes me feel alive. Anyway, when you npm install your libraries in some point in future, you can just get rid of this mapping here, and then the TypeScript compiler will expect your library as an npm installed package within your Node modules folder. The best thing about this is you don't need to concentrate on all these aspects because NX is taking care of this. NX has a lot of code generators that are setting up this structure and all these mappings for you. So let us also have a look into the package JSON of NX. Type package JSON. Here we see a lot of comments, and one of those comments is the dependency graph comment. Let's execute that npm run dependency graph. If you ask me, this is a quite nice feature. It doesn't make that many sense with such a simple demonstration application, but when you have a huge enterprise application, this provides real additional value when you can see which library is accessing which other library. Okay, so much for this. So we have seen the monorepo approach is a nice thing because it is the easiest way to substructure your big project into tinier parts, and it also prevents for version conflicts. So it seems like the perfect solution, doesn't it? Well, everything comes with disadvantages. Software architecture is just about finding the solution that has more advantages than disadvantages for your very use case. And when it comes to substructuring an application into sub-project, this also comes with a lot of disadvantages. I'm very sorry for this. One disadvantage are the dependencies between those projects. Each and every dependency is a contract, and we know it from the real world. It is very difficult to change contracts on short notice. It is not possible to change your working contract from now to then. You have to talk with HR and so on. It is not possible to change your renting contract from now to then. You have to talk with the owner of your flat and so on and so forth. So contracts are a bit of a downside. And this is especially true when you have different teams working on different sub-projects, because this also means you not only have technical dependencies, but also organizational dependencies. You have to talk with them. Yeah, and when I say you have to talk with them, it means you have additional complexity, especially when there are a lot of people involved, and this is normally the case when it comes to big enterprise applications. And this will postpone decisions, of course. And this can also block your tasks. Perhaps you know the situation where you want to start with your task, but you cannot start with it because you have to wait for your colleague to finish another task before. Or even worse, perhaps you know the situation where you have done your task, but you cannot publish it, you cannot put it in production because you have to wait for other tasks of other groups, of other colleagues to get finished. This is somehow a mess. And when we have a lot of sub-projects with dependencies, this also leads to a complex overall system. We only have one architecture for the overall system, one architecture for all those sub-projects. We just have one technology stack for all those projects, and it is hard to change something. And changing something is important for enterprise-scale applications because they evolve over decades. A lot of enterprise applications I'm supporting live for 10 or 15 years. And no one knows what situation we will have in 10 years. Perhaps in 10 years we have other technologies, or we have the situation that for a very specific sub-project, a whole other technology stack would be better suited. And changing something is very hard here. So more or less we have a one-size-fits-all solution where we have to live with our technology stack, with our architectural decisions for 10 or 15 years. And of course, this isn't fun at all. And this is exactly where microservices comes in. Microservices try to solve this issue by subdividing a big application into separate applications. So I'm not speaking about sub-projects here. I'm speaking about really individual applications that are just talking to each other by the means of well-defined interfaces, for instance, by some REST services or message queue. But more or less they are independent, and so they can develop independently and also deployed independently of the other microservices. The word microservice is mainly used in the backend. In the front end, we are also using the word MicroApp or micro frontend, but it is more or less the same. And of course, this concept of creating a lot of tiny applications instead of a big application comes with a lot of advantages. You have less complexity because you have a tinier application. You have less coordination. In the best case, you just need one Scrum team or just 2 or 3 people to maintain your application. They don't have to talk to the whole company when they want to change something. You can use different technologies. This is especially, as mentioned, important when it comes to long-term development, when the development, the evolution of your software lasts for 10 or 15 years. No one knows what we will have in 10 years. And no one knows if Angular is the best fit for each and every of our applications. So mixing technologies is important for this. And we also have a separate development and also a separate deployment. No blocking tasks that are coming from other teams. Of course, everything comes with disadvantages. This is what software architecture is about. You have a highly distributed system. You have distributed data because you have a lot of individual applications, and you need UI composition. You need UI composition because your customer isn't that much interested into microservices. It is a cool thing for us to have microservices, but the customer isn't interested into starting 70 applications in the morning. That would be a bit overwhelming, and so we need to concentrate on UI composition in the front end. The other disadvantages can be solved in the back end. So, of course, now the question arises, how can we do UI composition? How can we present all our applications as a common big application to the customer? And there are several solutions for this. The easiest solution is about using hyperlinks. Hyperlinks are the foundation of the World Wide Web, and it is really the easiest way to get started with this. But it also comes with drawbacks. One drawback here is that you are leaving your single-page application and entering a new single-page application when you are following a hyperlink. That means you have a postback, that means you need to load a lot of data, and that means you are losing your state. But it turns out that in some situations, going with hyperlinks is the right choice. Just think about Office 365. Each and every Office 365 application is a single-page application of its own, an optimized single-page application. And in the top left corner, you have this sushi menu, and it leads to this collection with hyperlinks that allows you to move over to other Office products. We have quite the same solution when it comes to Google. Google Maps, for instance, is a single-page application. You can use it. And then you have also such a sushi menu, and it leads to this collection with hyperlinks that also bring you to other single-page applications. And one thing that's here very important for me, I really want to stress it, please remember this, in Germany, there is a city called Steierberg. Yeah. It is in Lower Saxonia. Who of you comes from Lower Saxonia? Okay. One, okay, thank you. I like your Saxonians. Thank you for this. And it is also written in the right way. So please remember this. I think this is the most important information of this whole talk. Okay. So, of course, hyperlinks are not the best fit all the time. Sometimes you want to provide a shell application that is capable of loading all those micro apps just on demand. And for this, you have several options. And here I will start with the most ugly option. What do you think? What is the most ugly option? Iframes. Yeah, it's about iframes. I don't know about you, but every time I read the word iframe, I get this strange feeling in the stomach. It is somehow a bit frightening. But it turns out that iframes are not only bad. They have some advantages. The biggest advantage here is that an iframe provides the best isolation you can get. And isolation is important when it comes to shell applications. Isolation means that the one micro app cannot harm another micro app. An error here cannot affect the other micro app on the other side. A damaged CSS file, a fishy CSS file, cannot influence your design on the other side within another micro app. This is one of the advantages of iframes. And it is also quite straightforward. I mean, we have iframes for over 20 years, so they are really easy to use nowadays. But they also come with a lot of disadvantages. I'm just concentrating at 3 here. There are a lot of additional ones, but you have an issue with overlapping elements. You cannot lap a drop-down menu out of the iframe. You have a lot of page requests, and when you want to make SEO, hell breaks loose. So this isn't a good idea. But somehow you can live with those disadvantages, especially when it comes to in-house development. Okay, so much for iframes, the ugly, stable solution. When iframes are in this corner of the room, then the second solution are in that corner of the room. It's about web components. A new, nice standard that allows you to use custom elements. The idea is to create own HTML tags. And as a matter of fact, a whole application is just a component. Just think about Angular or other modern single-page application frameworks. There we have the situation that the whole application is just a component that consists of components that in turn consists of further components. And you also have the shadow DOM here. The shadow DOM gives you some kind of isolation for CSS. That means that a fishy CSS on that side cannot influence your layout on the other side within another micro app. You can even nest them. You can use one component from the first MicroApp within another MicroApp. That's very nice. The downside of this is framework support. Okay, to be honest, more and more frameworks are embracing web components nowadays. In this area, we have a lot of innovations nowadays, but it will take some time until the traditional frameworks have adopted it. Meanwhile, you can go with this solution. This is somehow an intermediate solution. It's about bootstrapping different single-page applications within one index HTML. And of course, that sounds a bit strange, but this is very similar to using web components. Instead of web components, I would use 2 Angular top-level components, 1 React top-level component, and a few top-level components. We have not a standard, and nesting isn't easy, but it is the best we have on the way to web components. Now I have a nice information for you. Perhaps you have seen it. Since 2 or 3 weeks, since Angular 6, we have Angular Elements. And Angular Elements is the Angular team's approach towards web components. It allows you to wrap an Angular component as a web component. And in the future, compared with new rendering engines, you will be able to compile your Angular application down to web components, more or less. So using Angular Elements is very easy. You just need to write an Angular component, you put it into your entry components, because it is instantiated dynamically at runtime. And then you need your injector and those 2 lines of code. Just 2 lines of code to wrap your Angular component as a web component. The first line of code is doing the wrapping. It is creating a web component out of your Angular component, and it connects it with the injector to get use of dependency injection. And the second line is already a command that is supported by your browser. It is the traditional command to register additional web components with your application. Yeah, and when you have done this, loading MicroApps is really easy. Just reference your bundle, and then you can use your own elements everywhere, like you are using custom HTML tags like table or div or input and form and so on. So let me use the last minute. Perhaps I am taking 3 additional minutes from you to demonstrate this. Let's start this up. Yeah. Here I have my application, and when I'm clicking here on the side, you are seeing that I dynamically loading MicroApps into my application, into my shell application. That means those MicroApps can be developed and also deployed individually, and they can be loaded just on demand by dynamically creating script tags and so on. Okay, a question that I get on a regular basis is, which solution should I use? And this question isn't easy to answer because it really depends upon your architectural goals. And normally you would have to evaluate all your architectural goals against the advantages and disadvantages of those concepts. And after a lot of discussions with my customers, I've created this decision tree. It is not the last word on this, but it turned out to be quite handy for getting a first decision you can discuss. So let me just have a look on this. The first question I would ask you is, do you have a lot of shared state? Do you need a lot of communication between your applications? And do you have a lot of navigation? When you say no, then go with hyperlinks. Because in this case, you have the same situation as you have with Office 365. You have a lot of individual applications, and hyperlinks are here the best fit as well as the most easy solution. When you say, yes, I have a lot of shared state and a lot of navigation between my MicroApps, then ask yourself the question, do I have legacy apps or do I need this very, 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 very strong isolation? And when you say yes, consider iframes, even though it hurts in the stomach as well as in the brain. And saying this, iframes are not a good fit for customer-facing applications. The next question is, do you need separate deployment and do you want to mix technologies over the next decade? And when you say, no, I don't need this, then chances are high that you don't need microservices at all. In this case, go with a monolith, but not with an ugly monolith. Use a so-called majestic monolith, a big application that is maintained in a very nice way, where you are taking about your architecture so that you can guarantee that not everything is accessing everything else. And when you say, yes, I want to mix and match technologies and I also need a separate deployment, then go with web components. And as mentioned before, you can also bootstrap several frameworks as an intermediate solution. So this is my decision tree for the macro architecture of your application, the architecture that holds all your microservices together. You also need some architectural decisions for your microarchitecture. That means the architecture of the specific microservice. And for this, you can use all the things we have discussed here. You can substructure one microservice using libraries and NPM packages. You can use the monorepo approach as well as web components and a lot of additional stuff I haven't discussed here. So it isn't a either-or this solution. So when you like this, I have blogged a lot about this topic. You will find a lot of information in my blog. And let me come to a conclusion. We have seen that we can use packages for reuse. We have seen we can use the monorepo to substructure a big application into tinier parts. And we have seen that microservices helps us with decoupling teams and decoupling big parts of applications. We can use the CLI6 for packages. We can use also the CLI6 as well as NX for the monorepo. And we can use links, iframes, and web components for microservices. So that's it. Thanks for coming. Here you have my contact data. Feel free to reach out. Thank you. Thank you.